All right, we're looking at answers to the tangent line approximations worksheet from Friday. Hopefully you found this pretty easy to do, but real quick, we'll run through the answers, make sure we got it. Number one says for the function f prime is equal to 2x plus 1 and f of 1 is equal to 4. What is the approximation for f of 1.2 found by using the line tangent to the graph of f at x equals 1? So we want to write a tangent line at this point. So that's going to give me y minus my y value and x minus my x value. I need a slope. Remember, to get the slope, we got to go to the derivative. So I'm going to plug 1 in here. So 2 times 1 gives me 2, plus 1 gives me 3. So that's why my slope is 3. So y minus 4 equals 3 times x minus 1 is my line tangent. And we want to approximate f of 1.2. So I plug in 1.2. 1.2 minus 1 gives me 0.2. 0.2 times 3 is 0.6. Add the 4 over. That gives me an approximation of 4.6. And that's why we have D as our answer. The second problem, they made it actually even easier on me. We're doing the same thing, which of the following is a tangent line approximation for f of negative 3.1. So I'm going to do y minus my y value and x minus my x value. There's my x and there's my y. And I need my slope. Well, they went ahead and gave it to me in my derivative right here. So my slope is 2. So that's why I have 2 plugged in. We want to approximate negative 3.1. So we plug in negative 3.1. If I put those two together, that gives me negative 0.1 times 2, which is negative 0.2. Add the 4 over, gives me 3.8 is my approximation. So that's why I've chosen A. 3 is similar to 2, but with a little bit of a twist. They give me my y values. They give me my derivative value. And we want a tangent line. And this time we're going to use it to approximate a 0. So if I'm approximating the 0 of a function, then that means my y value is 0. So I'm going to write my tangent line, and then I'm going to plug 0 in for my y value, and then solve for x. So y minus my y value, x minus my x value, and plug in my slope. We want to approximate a 0, so we're plugging 0 in for y. I go ahead and distribute the 5 over here. That gives me negative 2 equals 5x minus 15. Add the 15 over, gives me 13. 5 goes into 13 2 times. Only one of these answers has 2. So that means my approximation is 2.6. Now let's make sure we understand what 2.6 is. Again, we were finding if the tangent line to the graph of f at x equals 3 is used to find an approximation of a 0. So we were finding an approximation of 0. So we're saying that our graph touches the x-axis at approximately 2.6. That's what it is we found. We found the x value where y is 0. So that's what we were trying to do there. All right, number 4. So we have some data here. First thing we want to do is estimate f prime of 1.7. So here's 1.7. Remember, we can use 3 different things here. We could have used 1.5 and 1.9. We could use 1.7 and 1.9, or we could use 1.5 and 1.7. I chose 1.9 and 1.7. So we're using AROC to approximate the IROC. So that's 24 minus 23 over 0.2. So that's 1 over 0.2, which is 5. So that means f prime of 1.7 is approximately 5. So there's an estimation for f prime of 1.7. Then we want to use this estimation to write an equation for the tangent line of f at x equals 1.7. So y minus my y value of 1.7 is 23, x minus my x value, which is 1.7, and then I plug in my estimation from part A. So there's that. Now we want to use part B to predict the value of 1.8. So I'm going to plug 1.8 in for x. So I subtract that, gives me 0.1. So I have y minus 23 equals 0.5. So 23 plus 0.5 gives me 23.5. So my estimation for a y value at 1.8 is 23.5. Okay. And if you look up here, 1.8 is in here. It's doable that my estimation could be 23.5. All right. On these, hopefully you guys understood that we only wanted to do the box area because you have no clue on how to do B, C, or D yet. So we want to use the data to approximate or to estimate the rate at which the number of people waiting in line was changing at 5:30, which is when T is 5.5. Show the computations that lead to your answer. So again, we're approximating a IROC. We're going to use AROC to approximate that. We want 5.5. This time, 5.5 is not in my data, so that means I have no choice but to use 7 and 4. Anything but 7 and 4 is not going to be accepted on this one. So I need f of 7 minus f of 4 over 7 minus 4. So f of 7 is 150, f of 4 is 126. Subtract those, I get 24, and divide, I end up with 8. Okay, and notice my units is people per hour. Because my dependent variable is people, my independent variable is hours. So when I take a derivative of this, I'm going to get people per hour. So we were estimating the number of people waiting in line, or the rate at which the number of people waiting in line. So my rate at that spot is 8 people per hour. The line is changing at 8 people per hour. All right, next one. Estimate T prime of 7. So 7 is right here. Again, we have no choice but to use 8 and 6. So I'm going to use AROC using 8 and 6. So that's 55 and 62. So 55 minus 62 over 2. So that's going to be negative 7 over 2. Dependent units is degrees Celsius. Independent units is centimeters. So that's why we have degrees Celsius per centimeter here. Okay, and what does that exactly mean? That means that after 7 centimeters, or at 7 centimeters, the temperature is decreasing because of the negative at a rate of 7/2 degrees centimeters, or degrees Celsius per centimeters. So that's what that thing means. Next one, another estimation. We're doing R prime of 45. Again, there is no 45, so I have no choice but to use 40 and 50. So that's what I did. 50, R of 50 minus R of 40, so that's 55 minus 40, and that gives me over 10, which gives me 1.5. This time, dependent variable is gallons per minute, independent is minutes, so we're doing gallons per minute, and that's how we ended up with gallons per minute squared here. All right, next one. Again, we're estimating the radius of the balloon at 5.4 using a tangent line approximation. So this is back to the first stuff we were doing on the first page. So I need a tangent line, and then I want to use the tangent line to approximate 5.4. So here's my 5, and if you read here, it says the radius of the balloon is 30 feet when t equals 5. So that means 5 is my x value and 30 is my y value. So that's why I have y minus 30 and I have x minus 5. So now I just need the slope. I need the derivative at 5. So I go to my data. Here's 5. So that means my slope is 2 because I'm looking at the derivative here. So y minus 30 equals 2 times x minus 5 is my tangent line. I want to estimate 5.4. So I plug in 5.4, subtract this, gives me 0.4 times 2 is 0.8. Add the 30 over, and I am estimating the radius of the balloon to be 30.8 feet. Then this one has another one. Is your estimate greater than or less than the true value? Remember, we talked the other day, and we determined that if you want to figure out whether or not your estimate is an over or underestimate, you need to look at the second derivative and determine whether or not you're concave up or concave down. And if you go in here and read, it says between 0 and 12, the graph of R is concave down. So if I am concave down, that means my tangent line is above the actual function. And that's why I've written that we're dealing with an overestimate. So remember, concave down, you're going to have an overestimate. Concave up, you're going to have an underestimate. Last one. Write an equation for the line tangent to the graph of f at the point where x equals 1. Use it to approximate 1.2. So x equals 1, my y value is -4, and my derivative is 5. So y minus a -4, derivative is 5, so that's my slope, and then x minus 1. We want to estimate 1.2, so I plug in 1.2, subtract these. That gives me 0.2. 5 times 0.2 is 1. I subtract the 4 over. That gives me -3. Okay, so my estimate is -3. Again, this one wants to know, are we dealing with greater or less? Is my approximation greater or less than? So that means I've got to know something about the second derivative. And if you come in here, it talks about the second derivative right here is greater than 0, which means the second derivative is positive, which means my function is concave up. If I'm concave up, then that means the tangent line is below, and that means I'm dealing with an underestimate. So I said underestimate since f double prime is greater than 0 on the interval they gave me. So I probably should have actually answered it as less. They should take underestimate though. So my estimate is less than the actual value. All right, there it is. Worksheet from Friday, tangent line approximations.